Everybody hear me okay? Let's get right into it. I'm going to talk a little bit about JRuby today, give you some background on it, some internal details, and show you how you can use JRuby just about everywhere that you want to bring Ruby. There's my basic information. Full-time JRuby developer since 2006, almost 20 years now working on this project. I really love it. I love the Ruby community. I love being able to bring the power of the JVM to all of you. And I hope that you all are able to get something out of JRuby and learn a little bit from this talk. Most recently, founded my own company, Headius Enterprises, which is now funding JRuby development into the future. Hopefully, you'll be able to get some benefit from that and use some of our support services or help sponsor the project as well. Before I go on, I want to thank one of our customers who's here in the room, EasyBI. There's a number of folks that are at the conference, also sponsoring the event and sponsored my trip here. So a big thanks to EasyBI, users of JRuby all over the world, and for making it possible for all of us to be here today. Thank you. So I want to ask a question. What is it that you think of when you think of Ruby? Well, I've asked this to various people. Most people, the first thing they think of is, of course, the standard implementation, CRuby, MRI, right? That's what Ruby is. A lot of folks, the first thing that they think of when they come to Ruby is Rails. Ruby is Rails, right? That's what we do. That's what most people are writing Ruby for. But I would argue against this. I would say that Ruby is not just CRuby and Rails. Ruby is, of course, a programming language that we can do many different things in. We can build applications that are not using Rails. We can do a lot more than just building web apps. So I ask more questions here. Do you want to be able to use Ruby in more places? Do you want to be able to do more than just web development with Ruby? Well, of course we do. Do you want to be able to build other things? Want to be able to build mobile applications, desktop applications? Do we want Ruby to run faster and scale better and do more? Of course we want all of these things. And I would argue the best way to do that is by coming to JRuby and trying it out and bringing your Ruby skills to the JVM with JRuby. So let's get into JRuby here. JRuby is, of course, Ruby on the Java virtual machine. It's built partly in Ruby, partly in Java, but we leverage the entire platform. We try to make sure that JRuby feels like a Ruby implementation first. All the same tools that you're used to will work. You can bundle, you can use Rake, you can use Rails. It's all the same ecosystem and the same libraries. And then, of course, we're a JVM language, so you can integrate with the entire platform. You can use libraries written for the JVM in other languages and get the benefits of both worlds, the Ruby world and the JVM world. We generally say that Ruby code should just work. Anything that's just pure Ruby, if it doesn't run on JRuby, it's our fault, not your fault. You let us know, and we will find the problems, and we will fix them. We've worked very hard on compatibility. We don't have support for the same C extension API. We heard a little bit about that yesterday and some of the challenges of getting those to build. JRuby has its own extension API based on the JVM. You can write extensions in Java or Scala or Kotlin or whatever, and they will run out of the box, no build tools required. You just ship it and it runs. We also have the benefits of the JVM's parallel execution, parallel threading. So we don't need to fork off many processes. You can run an entire site in one process, and I'll show a little bit more about that scaling capability later on. JRuby's been around for at least 20 years of production users, 18 years of real-world use from major companies, and we're still going strong and keeping up with Ruby and trying to bring the best Ruby on the JVM to you. JRuby's also been leading the way in the Ruby world for many years. We heard in Matz's talk about some of the features and the work that's being done on YJIT and ZJIT. Well, JRuby had a JIT back in 2008. I wrote it for JRuby 1.1 many, many years ago and was the first native JIT compiler for Ruby code. We heard about de-optimization and doing a better job of re-optimizing code and profiling it, saving off JIT-compiled code. Well, JVMs have been able to do this for years. That's where JRuby gets a lot of its performance from. This class.new optimization that Aaron Patterson's been talking about, that Mott's mentioned. I did this back in 2015, and I'll show some examples of that. Namespaces coming up in Ruby 3.5 or 4.0, whatever it's going to be. We've always had the ability to run multiple JRuby instances isolated in the same process. You can spin up a JRuby, load code into it, run it in isolation, and then shut it down, all within one executable. So we've always been trying to move fast and solve all of these problems that are in the Ruby world and bring a better Ruby experience to developers like you. So JRuby really means opportunities for all of you to bring your skills, to bring the language that you love to a whole new domain, a whole new world. Let's look at some of these opportunities. Of course, there's lots of large enterprises running on the JVM. It's tested, it's tried, it's reliable and stable. Many large organizations out there that can run Ruby and can run JRuby alongside Java and Kotlin and Scala. We have heard dozens of stories from people who wanted to be able to build an application in Ruby, lived in a Java world, lived in a JVM shop, just bundled up the Rails application in a jar file or a WAR file, deployed it into production. Nobody cared. It was just great. Runs like every other JVM application. We have a whole bunch of people that are doing mobile applications using JRuby on Android. Android is a JVM ecosystem, and JRuby supports running Ruby applications on Android. Very recently, we talked with friends of ours in Oslo who built an application for the Oslo airport. The refueling terminals for the airplanes there are actually a JRuby-based Android application, using Active Record behind the scenes, running on a standard Android point-of-sale device. Desktop applications as well. A number of companies out there that use JRuby to build desktop consoles, desktop terminals, control systems for applications. All done in Ruby and all just using the JVM and the GUI components that are available. So lots of opportunities that you can bring Ruby to these different domains and build bigger and better applications that go much beyond what Rails and web applications typically do. So getting started with JRuby is pretty easy. All you need is to be on a platform that has a Java runtime, and pretty much every platform that's out there has a JVM available for it. The latest version of JRuby 10 requires Java 21 or higher. We also are still supporting our previous version, JRuby 9.4, which can run on older versions of Java back to Java 8. We always recommend that you just run on the latest version of Java because it'll be the most stable, the best performance. And then once you have your JVM installed and you've got it running on your platform, install JRuby however you install other Ruby implementations, or CRuby or MRI. The Ruby installers all know about JRuby. There's system packages for BSD and the Linuxes. There's Docker images that we publish with every release. Plenty of ways for you to get access to it. And if you are in a Windows environment, we even support Windows very well. You can download an installer, install it on Windows, and everything that you write will run exactly the same. No need for C compilers, no need for C extension headaches. It'll work anywhere. That's the power of JRuby. So here we have our Java version installed. This is off of my machine here. We're running with Java 24. We go to Ruby install. We ask it to install the latest version of JRuby, 10.0.0.1. We can drop into IRB just like with regular Ruby. We can check our Ruby version. That's the current version of what we support, basically the current version of Ruby. JRuby version, this one is the 10.0.1 that I was working on my local system. We can start calling into Java libraries. So here's the runtime class from Java, which can provide some information like the available processors in the system, the available memory in the system, and so on. I'll have more examples of calling into Java libraries later on. So, I mentioned Ruby compatibility. JRuby 10 supports Ruby 3.4. We're very excited to be essentially caught up with compatibility now. It's allowed us to work on other cool projects and cool optimizations for JRuby. The language and core specifications, which is the language itself, and then all of the classes like string and array and so on, 98% passing. And of course, there's things like fork in there that we won't support because the JVM doesn't support it. There are minor edge case features. The vast majority of things that you run are going to work perfectly out of the box. And JRuby 9.4, which is the older version that still supports Java 8, is running Ruby 3.1. If you are stuck on Ruby 3.1 and a little worried about end of life of that, that came up a couple months ago, JRuby 9.4 is still available for you. So let's talk about some of the opportunities we have in the JVM world, starting with the many different libraries that are available. This is basically a whole new world, a whole new ecosystem of cool features, cool libraries that you can use from Ruby because of JRuby. There's graphics libraries, graphical user interface libraries, different servers and ways of deploying applications, document formats, image formats, lots of work being done on AIs and LLMs in the JVM world, of course. It's really one of the largest and most powerful collections of libraries out there, and it's all available for Ruby developers. So let's look at some stats here. So here is the total number of gems on rubygems.org, 185,000. And as we heard, of course, from Marty, there's libraries in here that are abandoned. There's libraries that were pushed to 0.1 and never went beyond that. But we'll be fair and say 185,000. If we look on Maven Central, 700,000 different libraries that are available for you. And for pretty much, this carries on to pretty much everything that you might want. So one that I ran into at Ruby Kaigi was trying to find a good charting application or charting library. Some people use Charty, which actually calls out to Python to do its chart stuff. Other libraries use native libraries to call out and need build tools, need the right things installed on the system. About 300 different libraries for doing charting on Ruby applications. In the Java world, 1,200. Again, about 4 times as many options available for generating beautiful charts and graphics. And one of the examples I've done recently, this is a link to my blog post on using JFreeChart, a library for the JVM that provides a wide range of different charting behaviors, charting features, and of course, easily used from JRuby. So let's walk through a quick example here. So all the libraries in the JVM world are going to be published and packaged as jar files. And so like a gem file that pulls down Java, the Ruby gems, we have a jar file that lists all of the Maven coordinates, which are an organization or a group ID, an artifact ID, and a version number. So here we pull down some of the dependencies needed for JFreeChart. The lock jars command in JRuby is essentially equivalent to bundle install. It will look at your jar file, pull the libraries down into your local Maven storage, and then everything's available for that application to use. So we start out, we can Java import our Java classes into Ruby code. This is all just standard Ruby code here. You can also just assign these to a constant if you like the look of that better. We have Java import as a way of showing that we're pulling in from Java here. We're going to use the standard JSON library that comes with Ruby, and the gem that's out there ships both JRuby and CRuby support. Load in some data from this revenue monitoring company revenue data. We create a new data set for 3D data. And then for every element in our JSON data, we populate it into our data set. Standard Ruby, very simple to understand, and really, other than the lines at the top, you wouldn't necessarily even know that this is Java we're calling into. We create our 3D bar chart here and set some details on it, the color and where we want our legend to show up. And then we can generate a PNG file. We set the width and height that we want for our image. We create a new buffered image in the JVM, which is basically just a memory buffer where it can put the data for it. We ask the charting library, JFreeChart, to draw itself into this memory buffer. We open up a standard file using the regular Ruby APIs, and we use the Java image IO capabilities to write our image out to that file. All basically just Ruby code calling into a few JVM libraries along the way. And then we get our chart. And this is all very easily customizable. This is just with the defaults that I've set up in this simple example. There's many different types of charts in this library. It's well supported, and it provides easy output to portable network graphics, all the different image formats, and even to scalable vector graphics if you want, or to PDFs. So all available as free library on the JVM and easily callable from Ruby code. So I mentioned graphical libraries, graphical user interfaces. The JVM has one that ships with the JVM called Swing. Very easy to get up and going with Ruby and Swing and build a very simple desktop interface. SWT is a larger and more comprehensive toolkit that uses the native widgets on the system. You can write your code once for SWT, write it all in Ruby, and it will look like the native platform everywhere you go. You don't need to bind to just GTK or bind to just Win32 components. You write to SWT and it will look right everywhere that you deploy your application. And more recently, Java has introduced something called JavaFX, which provides more of a canvas for you to build your components out of rectangles, circles, and so on. Event handling, more modern way of building a user interface that's a little bit more similar to building a web interface. So a few uses of these. How many folks remember Why the Lucky Stiff or have heard of him? Yeah, there's a few. You should go look him up. He's one of the early folks that inspired Ruby to become very highly adopted. Lots of folks, he was their entry point into Ruby with his chunky bacon and his foxes that did Ruby coding. One of the tools that he created way back when was called Shoes. It was a very simple builder-like API for creating a little GUI interface, something simple for you to start with to get your feet wet in Ruby and try it out and play with little graphical interfaces. But more professionally, there's a library called Glimmer. Glimmer is a multiple back-end graphical interface library. It works with both JRuby and CRuby. When running on JRuby, it uses SWT, so it uses the native components as much as possible. But of course, you can use it to build games. You can use it to build whatever sorts of apps you want. Definitely recommend, if you're interested in doing desktop development, this is probably going to be the quickest way for you to get up and going with a really solid professional interface. I mentioned JavaFX. This is a short little example of what the structure of the JavaFX builder looks like. All 2D graphics accelerated because of the JVM, and still a very popular way to build more elaborate interfaces that don't fit into standard widget sets. And of course, I mentioned that we have JRuby on Android as well. The project is called Rubato. It's being updated right now for modern JRuby, modern Android. We've been chatting on our Matrix channel with some folks that want to be able to bring their game APIs to an Android app. And so they've been helping us get it updated and get it working with latest versions of JRuby and Android. This is a little demonstration of an IRB application, Rubato IRB running on a mobile device. Just a standard sort of IRB interface, but you can bring it up and show, test out Ruby features, show it to your friends. It has a very simple editor. You can load in scripts, and you can do all of the things that any Android application can do just with a little bit of Ruby code. So this is currently, it got pulled from the store because we requested all permissions so you could do everything. And it turns out that that's not great for security. So we're going to push a new version that only requests the permissions that you need in the more modern Android style. We also actually even have a plugin API for Minecraft. So this is a little bit of Ruby code plugged into Minecraft that it's basically changing how many chickens are released when you throw a chicken egg. This is a project by Tom Annabo, the other JRuby guy, or the other JRuby guy. And he likes telling the story that while he was developing this and playing with his plugin API, he actually ruined a world of his by creating so many chickens that the system crawled to a halt. He tried throwing more wolves at them, and it got worse at that point. So, but very easy to use. You plug it in. I think this used to be based on Bucket. I'm not sure what API it's using right now, but we're very interested. If anybody wants to play around with this, we can get it updated for newer APIs too. So let's talk a little bit more about other JVM features that JRuby brings to the table here. Of course, we have the legendary JVM garbage collectors. There's many options for tuning, many different types of garbage collectors for different loads. GC is never going to be your problem on the JVM. You can throw gigabytes, terabytes of working data at these applications, at these garbage collectors, never run into any problems. Some of these, like the G1 and the ZGC here, are meant to be pauseless. You can set goals for how much time it will spend in the background collecting objects. It'll size the heap appropriately, but ideally never pausing your application, even across hundreds of threads and terabytes of data. The JVM also comes with its own JIT. This is how we actually get the best performance out of JRuby. We JIT our code into JVM, and the JVM continues on from there and turns it into fast native code. There are other JVMs out there that have other JIT compilers. The Graal JIT, which can do some more aggressive optimizations, sometimes works very well for numeric applications. OpenJ9's JIT, which has things like offline JIT, saving code to disk. JIT servers, so you can have one process that does all of the JIT for all of your different instances. The CRIU, which is checkpoint and restore in user space, which allows you to save an entire JVM process to disk and start it up immediately at that point later on. So lots of options out there. All of them run JRuby just great. And now one of the really nice areas, we have some tools in the JVM, is for monitoring and profiling your applications. A few of my favorites here, Visual VM, which is a standard application that ships with the JVM. It's all open source, of course. A simple console for monitoring your application. And then the JDK Flight Recorder and Mission Control, which allows you to do profiling and monitoring of production applications with almost no overhead, 1 or 2% overhead for the simple profiling. If you add a little bit more, you can go up to 5%, but easily can be attached to a production server and see exactly what's going on there. This is Visual VM. On the left, we have the view that shows the CPU usage in the system, overall memory usage, how many threads are running, and so on. On the right is a plugin I love called Visual GC. This is a live view of the garbage collector in the JVM. You can see the different heaps being filled up and being collected. Some objects get promoted into old space. I believe this is running a red-black tree benchmark when I was doing it. But you can monitor the GC live on a system with this is almost zero overhead. This is basically just data that the JVM collects anyway, and we're viewing it on a client here. Here's a view from Mission Control. We are profiling allocations of objects, and we can see here up at the top, running the red-black benchmark, the largest allocation was, of course, the nodes in the red-black tree. Similarly, we have method profiling. These are the methods in red-black benchmark that were the most hit. Here I've filtered to just the ones that came from Ruby, but of course you could also see JVM libraries, you could see JRuby internals, and if there's problems outside of your Ruby code, it's not going to be hidden behind a native library, hidden in C, so that you have to learn how to profile C code. So we've got our tools, we've got our JVM, we've got our excellent GC and JIT. Let's talk a little bit about how JRuby improves the performance of Ruby. So I mentioned we depend on the JVM's JIT for doing a lot of the optimization work. We essentially teach the JVM about Ruby, how Ruby executes, and it goes from there and does all of its additional optimizations, all of the optimizations that makes the Java world, makes the JVM world fast, it applies them to your Ruby code. Very similar design to where ZJIT is going, but this is, of course, 30 years of work with dozens, hundreds of people out there. So hundreds and hundreds of man-years that have been put into the JVM's JIT compiler. JRuby itself also has an IR similar to the way that ZJIT is going. We use this for some optimizations before we give our code to the JVM. We do our own profiling and our own monitoring of that, and we have our own interpreter for it. So if we look at the JRuby architecture here, we've got our Ruby code that comes in on the left. We parse and compile that into our own intermediate instructions, our own IR here. And then we interpret that for a while, make sure that we're going to be using this code for a while before we spend time optimizing it. Once we find code that's hot enough, a method that's been called many times or is being hit very hard, then we turn that into JVM bytecode. We run it through this process, we pass that to the JVM, and then the JVM basically continues on from there with a similar sequence. It interprets the bytecode for a while, profiles the code, figures out how to optimize Ruby, and then turns it into native code at the end. So if we look at our pure Ruby red-black tree, this is basically walking a bunch of objects, creating a tree, walking them, searching, deleting, and tearing it down. JRuby 3.4, we have 15 or so iterations per second of this benchmark. I think it was walking the tree some thousands of times per iteration. We have the JRuby YJIT. Now this is actually compiling a lot of this code down to native, and we're very excited that YJIT has come so far and is bringing so much better performance to Ruby applications. But of course, we've got the JVM to lean on. We're still able to exceed the performance of YJIT, and this is before I started doing any of the JRuby 10 optimizations that I'm going to show in a little bit here. So very nice performance. If you run into something on JRuby that doesn't run as fast as you think, or seems like as you would think it should, or doesn't run as fast as something in JRuby, just let us know about it. There's probably some work that we can do to get there. Class.new optimization that I mentioned earlier. So JRuby is adding this. It's coming along. I think it'll be for Ruby 3.5, 4.0. Some early examples of this, and it looks like it really can help the performance of allocating objects. But JRuby's had this for many years. We teach the JVM how class.new works. Allocate an object, call initialize on it, and then we've got our object. By teaching the JVM, we can get significantly better performance out of it, and it inlines and optimizes just like any other piece of code on the JVM. So let's look at a benchmark of object.new, just creating new objects as fast as possible. We have Ruby 3.4, just with basic YJIT without this optimization, the opt.new function, opt.new feature that's being created. 10.3 million allocations of objects per second, very good. With the new optimization, about 30%, that's what Aaron expected when he started working on it, 30% improvement in performance, because now YJIT can actually optimize through the object, it can optimize the calls to initialize, it doesn't have to call out to C code for it. But then we run the same thing on JRuby. A little bit different here. The JVM is well taught about how these objects are being allocated. It knows how to allocate objects very quickly and throw them away very quickly, also very important. And so completely off the scale here. We'll go to a logarithmic scale for the rest of these, just so you can see this a little better. And now this also applies to custom objects that have their own initialize method. Of course, object.new, that should be pretty easy to allocate quickly. But what about when we have our own Ruby code in there? Again, the amounts are pretty much the same. Ruby gets a 30% improvement here, a little bit better than it was before, but JRuby way up on top. Again, 200 and some million allocations per second. And now I was actually a little surprised by this. I wasn't sure that it should be this fast. It seemed too fast to me. So I went back into some of the JVM tools like Mission Control and did an allocation profile. And yes, indeed, it is actually allocating those objects. So there's no trickery here. It's creating those objects many times, 10 times faster than JRuby can, even with the new optimization. And now I mentioned, of course, there's other alternative JITs, alternative JVMs. The standard OpenJDK JIT is called Hotspot, generally going to be the best overall performance for applications. But there's the Graal VM is another JVM that has its own JIT called Graal. And it can do some additional aggressive optimizations, sometimes unpredictable performance, sometimes a little bit slower on JRuby, but for certain loads, it may actually be faster. Let's see what happens when we throw this at it. So here is our performance on JRuby 10 with Hotspot. Here is the performance of this benchmark running on the Graal JIT. Another order of magnitude performance. Now, how is this even possible that it's that much faster? Like, if you do the math on this, 2.5 million iterations per second, we're talking about like a nanosecond per instruction, or per object. The trick that Graal does is it sees we're running a benchmark, creating all of these objects and never using them, just throwing them away. It eliminates that entirely. Now, what does this mean for your application? It means that if you have objects that are being created, very temporary objects, only being used for a short period of time, the Graal JIT may be able to eliminate the object altogether and keep your logic in place and executing the way it's supposed to. Very recently, I came across an optimization that would make a lot of sense for JRuby. Optimizing respond to when you give it a specific name. So this pattern, toStr, but only call toString when you know that this object is stringable, when you can convert it into a string. This should be something we can optimize quickly, so I decided to do it, and it took about 2 hours on a flight. So here's the pattern that we're going to optimize. Call the foo method only if it responds to foo, right? So here's how it works previous to this implementation. We have our respond to call come in. Now we know we need to invoke the respond to method and see if the foo method is available. So we do our call. Okay, now we need to look up the respond to method. Is it cached from a previous call? Okay, it's not cached. We go out to the class. We look up the respond to. We cache it in our call site so that we don't have to do this lookup every time. And then we can invoke it. And of course, from here on, we can just go straight to that point. We know we've cached the respond to method and jump right into it. So that's part of the optimization. But then the way it worked before is we essentially did this all over again inside respond to. We would go look up the foo method, check if it's implemented, and then return a true or false result depending on whether it's available. But this is the same thing. We should be able to cache this information as well. So I taught JRuby and taught the JVM how to do that. So here we have our old version where we just call down into respond to does its slow lookup of the foo method. But now, instead, we actually can cache that result. Once we know that the foo method is defined on a class, unless that class changes, unless the method table changes, we know it's always going to respond to that method. So we can go straight into it and return the result right away every time. If something happens in the future, a method is added or something's changed, we throw this away and we do the caching all over again. So here's CRuby with YJIT on that benchmark, running a benchmark of foo if respond to foo. JRuby 10 without the optimization, and then JRuby 10 with this optimization. At this point, the respond to is now basically free because it's all cached just like a normal call site. And these are the sort of optimizations that we're able to do now that JRuby's caught up on compatibility. You're going to see lots more of this over the next few months. So finally, scaling applications. So this is kind of the classic problem on CRuby. We don't have concurrent threads, so if you want to do things in parallel, you need to spin up worker processes. And all the copy on write tricks in the world are not going to avoid duplicating some amount of runtime state in each of those processes. Plus, you're going to have that many garbage collectors that are all trying to fight for memory. You're going to have that many JITs that are all doing their own optimizations. It's an inefficient way to scale up a large application. JRuby is an excellent solution for this. We have a multi-threaded single process running all requests in parallel. You can run your entire site in one application, one process, without forking, without managing workers, and without duplicating all of that runtime state. So let's take a little baseline Rails application. This is just the generated blog application from Scaffold. So we'll throw JRuby and CRuby at this. Now this is to be totally honest and totally fair. That optimization process does take a little bit of time to get going. Sometimes JRuby itself will take a little bit to optimize. The JVM takes a little while to get things up and going, but then clearly it exceeds CRuby and YJIT performance on this simple blog application after just a little bit of extra running. We'll look at this more directly here. 1,700 requests per second on this simple application. This was going out full end-to-end, going out to Postgres, rendering the page, and bringing it back to the user. So let's talk about memory and scaling. Of course, that was part of the problem of having these workers. JRuby, when you tune it for this application and have about a 300 megabyte heap, the rest of the JVM adds about 700 of its own state. They were running at about a gig for that single process. And now if all you need is one instance or two instances, JRuby maybe isn't the thing that you need. Maybe you're doing just fine on CRuby. When we start scaling up from there, though, you may want 100 users. You may want 200. You may want to have 1,000 concurrent requests that are being handled very rapidly. Then things start to go up and get scaling problems, and you're starting to use more and more memory on your instances. So graphically, we start out with JRuby using too much memory compared to CRuby for a small instance. This is for scaling large applications, but you can get a lot of good performance from there. And then 16 users, JRuby, CRuby is starting to catch up on the amount of memory that it needs to be able to handle 16 concurrent requests. I think I was doing 2 threads per worker here, just to not overload it too much. And then of course, up to 160 users, now we're just linearly going up. We need more workers to handle all of those concurrent requests, and each of those is going to require its own memory. And now this is all possible, of course, because JRuby has excellent concurrency capabilities. So let's talk about threads and ractors. Ractors have been developed over time in Ruby to bring concurrency, bring parallelism to CRuby. It's tricky to use, though. You have to write ractor-friendly code. You have to be passing pretty much only immutable objects across that boundary. And even then, you're still going to have issues getting the performance that you want. There's a lot of overhead crossing that boundary into ractors. Threads in JRuby, 100% parallel. You can use your existing Ruby code, you can use all the same libraries, all the same applications, and scale it parallel across all of the cores in the system. Masha, who works on Karafka, helped me out with this benchmark, so thanks to him. So we're basically just going to spin up a bunch of threads. Each thread is going to parse in some JSON data and then pass it off to a worker to continue executing. And we're going to do this same thing in CRuby and in JRuby. CRuby with threads and ractors, and in JRuby with threads. So let's try CRuby with threads. Don't get a whole lot of improvement. We can only run one of these threads at a time on the system, so a slight improvement because in the background, Ruby is able to parallelize a little bit of its own internals, but largely not seeing the gain we would get from the 4 cores in my system. Ractors help a little more, but again, we're still not getting the performance that we want out of this. There's still fighting for the garbage collector, it's fighting for other resources in Ruby, and you don't get to parallelize as much as you like across those cores. Now, if we run it in JRuby, of course, it's about a 4 times improvement. We're using all of the cores in the system, running the exact same code with threads that we ran on CRuby, and getting much better scaling, taking advantage of the entire hardware of the system. All right, so wrapping up here, JRuby's future is looking really exciting. I'm very happy that we are continuing on with the project. I'm happy to be able to bring it to you. JRuby 10.x, we will continue working on this year. Many more of these optimizations coming. And if you have ideas for them or see specific things in your code that could be faster, let us know. There's probably a way that we can find out an optimization that might make it 5, 10, 100 times faster. We're going to be utilizing more and more of modern JDK features. This was a big motivation for us to jump to JDK 21. There's features that massively improve startup and warm-up time of JRuby applications. There's fast integration with native libraries. So we can use FFI to call out to native libraries, and it'll optimize almost like it's calling just another Java library. And the JVM itself continues to get faster with every release. You upgrade your JVM, your application's probably going to be faster as a result, just by doing that simple process of upgrading. So JRuby and you, well, if you're building an application, try out JRuby. Let me know if anything doesn't work. Let me know if it doesn't perform the way you want. You can use Bundler. We recommend Puma if you're using web servers. It works great. All of my benchmarks were done with Puma. Try out some of the JVM libraries that are available. Maybe you've got a pain point in your application, something that hasn't been well supported in the Ruby world. There's probably a library out there for the JVM. There's probably 10 libraries out there for the JVM, and maybe one of them is even good. So check them out, and you'll be able to find what you need. Are you an author of a Ruby library? Well, put us in your CI pipeline. Put us in your GitHub actions. Test on JRuby, make sure it continues to work, and keep us honest. Let us know if we break something or if we don't run something the way that you expect it to. It's probably our fault, not yours. And I'll be here. Let's talk. If you're interested in anything that you've seen here, come and talk to me during the Open Source Summit, and we can make something happen for you. JRuby development itself, funded fully by Headius Enterprises now. This is my company, and we are working with JRuby users, partnering to bring support opportunities to them and to help them fund the community and fund the ecosystem for JRuby. So if you want to run this stuff in production, please partner with us. We can make sure that it runs great for you. And then, of course, if you have a few extra bucks laying around, I'm happy to take sponsorship, interested in any grants that might be available to keep the project going. I think this is very, very important for the Ruby world that JRuby continues to move forward and continues to bring the best parts of the JVM to Ruby developers like you. And that's all I have today. Thank you.